Yesterday we talked about the Chesapeake Bay. If you were not here, listen up. Where's the Chesapeake Bay? Yeah, the northeast up by Washington, D.C. Okay, you don't need to write this stuff. Some of it's written for you. What were some of the issues with the Chesapeake Bay? What was flowing into the river? Yeah, what kind of pollution? Runoff from agriculture like nitrates, phosphorus, and remember sediments. Yes. And they're creating dead zones where there's no oxygen. We'll talk about that today a little bit. Okay, so that was kind of our recap. We looked at the Chesapeake Bay yesterday. So we're talking about water pollution. What are the pollutants that pollute water? You guys already know some from the lab. Where do they come from? What are the laws regulating them? Why are they a problem? Okay, all those different types of things is kind of in this unit. Do you need me to go back? Yeah, can you go back? Mm-hmm, sure. Yeah, it was a video. But since we read the article, I'm going to skip the video. I don't know. I make things and then I forget that I make them. And then I'm like, oh, here's an article on the Chesapeake Bay. And then I forget that I put a video here. And yeah, I think I just have like amnesia or something. All right, wastewater. So one major type of water pollution is wastewater. Wastewater comes from livestock and human activities. If you just want to write that, I don't anticipate you ever needing to know the exact definition of wastewater. It does include sewage, gray water from bathing and washing clothes. So we're not necessarily talking about...
Pardon this interruption. Students, the JV track meet has been postponed. Please report back to the class that you're scheduled for at this time. Thank you.
So we're not exactly talking about like industrial waste. We're talking more about, you know, human activities. We're talking wastewater treatment facilities, livestock, that kind of stuff. We'll get into like heavy metals and toxins later. But in terms of wastewater, it's generally just talking about, you know, general human activities, not including manufacturing and industrial waste. So when we talk about these wastewater, or this wastewater, it's this big umbrella term, okay? And it includes lots of different things. And we're going to learn that there are two different types of pollutants or two different types of sources where wastewater can come from. So I actually misspoke. This doesn't include industrial waste. This includes all wastewater. We have something called a point source and a non-point source. A point source is something you can point at and say, hey, the pollution's coming from here. It's one specific thing, like a factory or a water treatment plant. You can trace it because you know there's specific chemicals that come from that specific location. So if the jockey factory is pouring a whole bunch of its extra wastewater into a stream and it's got all the chemicals they use to make their underwear, right, we can trace it back and say, hey, you need to stop dumping this in the stream. The Clean Water Act, that's what part of the Clean Water Act does, is it puts regulations on who can dump what where. We also have non-point source. This is pollution produced by a broad general area. So a farming region, storm runoff, something like that. If you have road salt that's getting washed into a stream, and you say, oh, there's a bunch of road salt in this stream, can you figure out where that road salt came from? Probably not, because it came from a lot of different roads. Okay? If you have manure into a stream, can you figure out where that manure came from? There's a lot of farms in the area. It could have come from upstream. It could have come from a far ways away. So it's hard to figure out. So non-point is just this big, broad, general area. So on the next page, you have a picture. We're going to label this picture. All of the numbers are non-point sources. Okay, so all of the numbers are non-point sources that we're going to identify. Big, general things that typically we can't say, oh, they came from one point or one source because they're hard to trace. Okay, so number one, what does it look like this guy's doing? Yeah, dumping. So littering or dumping, right? If you find a plastic bottle in the stream, can you figure out who it came from? Probably not. Okay, so that for that reason, it's non-point. Sure, it's coming from him. He's one person we can point at. But if we find it, we can't say, oh, we know it came from this exact person. Okay. Number two, what is this pipe from, do you think? Yeah, this is from the stormwater runoff, right? So like runoff from the roads, the culverts that you have. So this is just runoff from the roads. If it was a sewage treatment plant, that would be a point source, right? Because we could track and trace, like, oh, this has all of these terrible chemicals that are found in sewer plants, and it's coming out right here, okay? Three, this is an oil spill, right? So spilled gasoline or oil. Again, it's really hard to trace where that comes from. Now, if it's like a big ship or tanker in the middle of the ocean and it gets collided into and it's oil spilling all over, that would be a point source because we can say, oh, all of your oil is spilling out of your boat, right? All right, number four, here we have some more litter, garbage. 5, what do you think 5 is referring to? What would be on the grass here? Yeah, fertilizers, pesticides, yeah, all of that. So fertilizers, we can't trace where the fertilizers come from. They're going to wash into the stream. 6, he's mowing the yard. So yard clippings or yard waste, things like grass, leaves, branches. 7, here's another guy dumping something. I have no idea. We're just going to label it dumping or littering, either or. 8, we've got a sidewalk, right? So we've got runoff, right? Runoff from the water. These are all non-point sources. Yep, they're all non-point sources. So you might be like, oh, well, the litter comes from this one place, so it's a point source. It's not. Okay, it's not because we can't be like, oh, we're going to trace this litter all the way back to this person. We don't know who did it. Okay, whereas if it's an industrial, like if it's a factory, we can say, oh, because you have this concentration or these particular chemicals in that we found, we know you produced those, so we know that it was your fault. All right, 9 is acid rain. Remember, that's from nitrogen and sulfur, nitrous oxide and sulfur dioxide, sulfuric acid, nitric acid. We can't tell where that air pollution came from. Okay, sure, it's mixing into the clouds and creating rain, but we can't tell. And then 10 is a farm. So, yep, it could be either manure or pesticides or fertilizer, any of those different things. So these are all non-point sources. I know I wrote at the top of your note packet, highlight all the non-point sources. I was going to have you do that, but we're not going to do that. A point source, what could be a point source? Well, if this factory was discharging something into the water directly, yeah. So typically point sources, you just have to remember factories and like water treatment plants. That's pretty much the only thing. And everything else is non-point, okay? Oh, yeah, sorry, I forgot about 11. Yep, so this would be sediment. Thank you for reminding me. Are there any more? No. Okay, so sediment. Good. So what problems does this cause? We've talked a little bit about it. One thing we can measure, we can literally go to a stream. We can measure something called biochemical or biological oxygen demand. If it demands a lot of oxygen, that means there's not going to be a lot of oxygen left for the fishes. Okay? So the amount of oxygen an area uses over a specific period of time. If they're using a lot of oxygen, that's where we get those big dead zones where there's no fish or no wildlife. And that's a problem because wastewater is going to decompose. It's also going to create a lot of algae and microorganism growth. And then when those guys decompose, they're going to require lots of oxygen. So biochemical oxygen demand, the amount of oxygen that an area of water uses over a specific period of time. And you can do tests to figure out how much oxygen is in the water. So if you have a high biological oxygen demand, you're going to have a lot of wastewater pollution in there. That indicates that there's a lot of pollution because there's not a lot of oxygen left over because all of it's being used up for decomposition. If there isn't a lot of oxygen, a lot of times we get dead zones. So we will get fish that just end up dying. Okay? Where the Mississippi River ends up flowing into the Gulf of Mexico, we have a huge dead zone, the size of Los Angeles, or not Los Angeles, sorry, Louisiana right here, right? This is the coast of Louisiana. The entire coast here is one big dead zone where nothing can live because there's not enough oxygen. So a dead zone or hypoxic zone is an area becomes so depleted of oxygen that little ends up surviving. So underneath how are dead zones created, we're just going to write a couple steps on how they're created, and then we'll talk about eutrophication, and then we'll pretty much be done. Okay? So if we look at these dead zones, how exactly are they created? Yep, runoff. Okay? So the Mississippi River carries nitrogen-rich material like fertilizer, runoff, and sewer. So we're going to write fertilizer and sewer run. So fertilizer and sewage run into the water. So that would be the first step. And then any of the microorganisms or organisms that feed on the nitrates or phosphates are going to explode in numbers, okay? So we get increased populations of algae and other organisms. And then organisms die and consume all the oxygen from decomposition. So this whole process is called eutrophication, right? You need to know that word for the AP exam. Eutrophication is a very important word. We're going to write the definition down in a second. So eutrophication is when a body of water becomes rich in nutrients, causing rapid algae growth and then eventually dead zones or hypoxic zones. All right, lastly, wastewater can bring diseases or disease-causing organisms into the waterways. Okay, so historically, a lot of people use the same water for drinking, bathing, sewage. Okay, so there's a lot of disease that gets mixed in with that. The major waterborne diseases are cholera and hepatitis. There's a lot of other diseases as well. 1/6 of the world's population does not have access to safe drinking water. A lot of times we'll test water quality by testing for E. coli, or what we call fecal coliform bacteria. This is bacteria that grows in fecal matter, feces, right? And one of those is E. coli. So if we test it, we know that there's probably untreated sewage in that water, and it's probably not safe. Okay. All right, for the rest of class, you are going to work on your lab. If you are done with your lab, I want you working on the big review packet. I technically would like up through page 6 done for tomorrow. So that's what you are working on.